Hey guys, this is Mr. Kilburn. I'm going to give you a brief introduction to our next topic, which dovetails off what we were just learning over the last 3 weeks. Equations, linear equations, slope, y-intercepts, and all that good stuff. The quiz redos were much better, so good job. Well done. Okay, so the next topic is going to be what's called systems of equations. And the first way we're going to learn how to solve systems of equations is by graphing. Now, systems of equations may sound complicated, but it's really not. It's just two lines on the same graph. Okay, there could be 3 or 4 or 5 or 6 lines, but for our purposes, it'll always just be 2 lines. Okay, so the way you solve a system of equations, 2 equations on the same graph by graphing, is simply to do what you already know how to do, and that's graph the lines. So suppose you were told to find the solution to the system given these 2 equations, y equals 3x minus 4 and y equals negative 2x plus 1. So the first thing you would do is graph the 2 lines. Okay, so there's y equals 3x minus 4, and here is y equals negative 2x plus 1. All right, so before I really even say anything else, where is the solution to the system? And if you were thinking like a pirate and you thought X marks the spot, that would be very good. Let me bring up a, let's see here, creative pen, happy face, and yep, right there. Okay, so the solution to this system is at the point 1, negative 1. All right, and because the lines cross one time, there's one solution. Okay, obviously lines can't cross more than one time. By definition, they're straight, so either lines are going to cross or they're not. Okay, so there's the first example. So the 2 lines cross, and that should make sense that they're going to cross, because what about them was different? That's right, the slope. The y-intercepts are also different, yes, but the slopes are different, so at some point they're going to cross. Okay, next example. Okay, suppose you had y equals 4x minus 6 and y equals 4x minus 2. Okay, so y equals 4x minus 6 is right here. Somewhere, maybe. Maybe not. Hang on. Oh, I see, because the stupid letter thing he was on. Okay, hang on. Almost there. Don't fall asleep. There we go. Okay, there's y equals 4x minus 6, and there is y equals 4x minus 2. Okay, how many solutions do you think there are to this system? Good. If you said none, that's right. Because where are these lines crossing? And they're not crossing. They're parallel because they have the same slope. So since the slope is the same and they don't cross, they're parallel, there's no solution to this system. Just like we solved equations we ended up with, say, 5 equals 19. We recognized that there was no solution. What it looks like graphically is 2 parallel lines. They never cross. Okay, so the last possibility is to graph a system excuse me, with an infinite number of solutions. So suppose you had y equals 9/3 x minus 5 and y equals 3x minus 5. Okay, so if I were to graph that line, and then, so this is up 3, 1 to the right, up 3, 1 to the right, and I graphed another line that went through negative 5, but I went up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, over 3, it would match up perfectly. Okay, so these lines, these equations graph the same line, therefore there's an infinite number of solutions. Every point on the line is a solution because it's basically just the same line on top of itself. Okay guys, there you go. So there's 3 possibilities with systems graphing. One solution, the lines intersect at some point. No solution, you have 2 parallel lines with the same slope so they don't cross. And 3, infinite number of solutions, where you have 2 equations, same slope, same y-intercept, and they match up perfectly on top of one another. There you go, guys. Have a great day. Take care. Bye.